Okay, so today we are looking at roots of complex numbers. So this is our learning intention. Our learning intention is to gain the knowledge of building our understanding of the roots of unity, to calculate the argument and modulus of the roots. Okay. We'd be successful if we can calculate the roots of a complex number and plot the roots on the Argand diagram. Just grab me a black pen. Okay. Alright, so roots of a complex number. The solution to z to the power of n equals a plus ib. And these are equally spaced 2 pi over n radians apart around the origin, starting at z1, being r equals cos theta plus I sine theta, where theta is the argument of a plus ib over n, and r, the modulus, is the nth root of the modulus a plus ib. Alright, let's do some examples. Alright, we want to solve z to the power 5 equals negative root 3 plus I. So before we were doing things like negative z to the power 5 equals 1. Right? But now we're going to do things where they're not equal to 1. So it's not about the unity, but it's a different complex number. Okay. So the first thing I have to do is, obviously, so in this situation, n equals 5. All right. The modulus of z is root 3 squared plus 1 squared. So 3 plus 1 is 4, square root of that is 2. And the argument is tan 1 over root 3. What I'm going to do first, before calculating the argument, is I'm going to actually sketch where z to the power 5 is. Okay, so negative 3 plus I. So here is my z. Okay, so this is going to be the argument that I require. Okay, so using my calculator, shift 10 on 1 over root 3 gives me 30. Okay, so 150 over 180. So the argument is actually 5 pi on 6. Okay, so they're the first three things I need to find out. Okay, from here I can now find out where my other roots are. I'm going to start with I want to find so my r. So using these formulas here, r is going to be n over a plus ib, and theta is going to be the argument of a plus ib over n. So in this situation, n's 5, and my a plus ib, maybe I should do that. Right, is 2. Now in this situation, my argument is 5 pi on 6 divided by n, which is 5. And that works out to be 5 pi on 6 divided by 5 over 1, which is 1 over 5. That cancels that, leaving me pi on 6. Okay, so now with this stuff I can actually find my arguments. I also need to also calculate what 2 pi on n would be. In this situation, it would be 2 pi on 5. So actually, once I found these three things, I then need to find these three things. Okay, so one of my roots, I won't label them just straight away. Alright, it's the fifth root of 2, I'm just going to write it in, so cis pi on 6. Yeah. The next one is going to be cis pi on 6, right, plus 2 pi on 5. Maybe I'll do it here. So 1/6 plus 2 over 5 is 17 pi on 5. So this one's going to be 17 pi on 30. That's fine for that one. I'm going to get the next one, which will be cis 17 pi on 30 plus 2 pi on 5. So plus 2 on 5, which is 29 on 30. So the next one is going to be 29 pi on 30 plus 2 pi on 5. So I get 41 on 30. So 41's bigger, so it's gone over. Okay, what's that? That's 246, so I have to minus 180 from that. So I've got 66 over. So 180 minus 66. So I should have negative 19 pi on 30. So negative 19 pi on 30. And because there's 5 to the power 5, I should have 5 roots, so I need one more. So that's going backwards, so it's just minus 2 pi on 5. So 1/6 plus 2/5 is 17 pi on 30. So this is, sorry, plus, that should be a minus. Sorry, 7 pi on 30. Now, if I was to minus 2 on 5 again, I should get 19 pi on 30. Excellent. So, once again, so we're going to figure out your n, your modulus, and your argument. Always try to have a sketch so that you can figure out which is your principal argument. Then calculate your new r, your new theta, and then obviously the change, so 2 pi on n. Calculate your roots. Now, it says the Z1 starts with the first root in the first quadrant. So looking at this will be your Z1. This is next, so that's Z2, Z3, Z4, and Z5. Yeah, going around in an anti-clockwise direction. So if we want to sketch it on our Venn diagram, so we're changing it, everything moves basically by 30, and we get Z1, Z2, Z3, Z4, Z5. Okay. So one more example. We're going to determine the roots of z to the power of 4 is equal to -1 minus 1 over root 3. Okay. So, the first thing I'm going to figure out is, obviously, I need to figure out what, so in this situation is going to be 4. So the modulus -1 squared plus -3 squared, oh, this is another one, so 4, so it equals 2. So, yeah, and my argument, so I'm looking at for this angle here. Okay. So tan of root 3 over 1 should be 60, so negative 120. So negative 2 pi on 3. Okay. So my new R is using that formula of n. So it will be 4 to the root 2. And my theta will be, so the argument of that over n, so negative 2 pi on 3 divided by 4, which is times it by a quarter, so is negative pi on 6, and then obviously the change is that 2 pi over n, so this way it should be 2 pi over 4, so it'll be pi over 2. Okay. So let's calculate the roots. Okay, so one of them will be 4 on root 2, cis negative pi on 6. Now that's somewhere here, so that's not going to be my Z1. Okay, just be aware of that. Okay, so maybe I just put Z, another Z. So if I was to go forward, all right. So negative 1/6 plus a half gives me cis pi on 3. So pi on 3 plus pi on 2. Gives me 5 pi on 6. The next one's going to jump over. So I might want to do this instead. Subtract it rather than add it. So negative 1/6 plus, minus a half. So negative 2 pi on 3. So, and I need to have 4 roots. There's 1, 2, 3, 4. So technically, this here is my Z1. This would be my Z2. This would be my Z3. And this one is going to be my Z4. okay, because it goes in a clockwise direction. Okay, so that's it. Thank you very much. Good luck.